sometimes you want to store pairs of key values as a collection, so keys and values as a collection, and you want that to be accessible really fast. So let me just restart this kernel for a second there. And for that you would use dictionaries, right? So dictionaries you define using squiggly brackets, like so, with keys followed by colon, followed. Keys can be any immutable type. They can be different. Let's say there are integers now. So the first key is 2 with an associated value of 45. Then the second key would be, let's say, 3 with an associated value of the string 3. 10 with value 10, and so on. You can technically have keys of different types too. So here floats, for instance, or the string 2, right? This is a legal dictionary, but generally is not used that much. Generally, dictionaries are used for mapping such as this indeed. So 2 with to map between integer value, for instance, and string values and similar things. Accessing a dictionary by key is really fast, as opposed to accessing an element in the list. There are advantages to dictionaries. For now, just let's talk about their structure. So you can get the collection of all keys using the keys function. The dot keys gives you back a list-like keys. Sorry, it gives you back a list-like structure where all the keys are enumerated. Sorry, we want the keys for that dictionary. Okay, keys 2, 3, and 10. You can use the list function to transform it into an actual list, 2, 3, and 10. Similarly, you can use the values keyword, so d dot values, to return all the values in the dictionary. And you can put it inside a list. And you can check whether a key is in the dictionary by using the in keyword. So let's see, 4 in D should give us false because we don't have 4 in the dictionary, not as a key, not as a value neither actually, but 2, for instance, is in it, so it should give us true. Note that the in keyword actually looks inside the keys and not inside the values. So actually d dot keys should give us the same result. And looking inside the list, the in keyword can be used to look inside the list just the same. So it's a list d dot keys. It should be also true for inside this list. No, it's false. You can actually use int to look in any collection tuple. For instance, this should also give us false, but 2 is in the tuple consisting of all the dictionary keys. Let me just print out how it looks, right? Print how the tuple of dictionary keys looks like. So d dot keys. My bad. Keys is a function. There we go. So you see, you can call using the names of the different collections, so you can convert from one collection to the other to a certain degree. You can't create a dictionary from a list, but you can create a list from dictionary keys or from dictionary values, or tuples from lists and lists from tuples and so on and so forth. Right? As long as the structure is the same, is flat. To add an element in a dictionary, you can use the access operator here. This is actually how you access keys too, or using get. I'll get to that in a bit. So I want to add another mapping for 9, and the value associated with this key, so the key is in brackets there, and the value is past the assignment operator. That will be 9. 9, exactly, and let's print D now. There we go. We have a new key value pair, 9, with the textual version of the number 9. To change a value, so dictionary are mutable, you can change them. You go and access a key that is in this dictionary, and you simply assign it something else. Let's put the number inside this time as a string and print the dictionary. There we go. The last entry is 9. Note that this is actually not sorted, so you cannot assume that the key value pairs will always be in this order in general. Okay, to get the value, you can either use the brackets with the respective key. So dictionary at 9, this should give us 9 as a string. Dictionary at 2 should give us the word 2. Or you can use get. Why would we use get? And so it's basically kind of similar. Print, it's a function call, quite like the others, like keys for instance. Print d.get, let's say 3. I want the word 3 now. There we go, we got 3 back. Now, there is one distinction between using the access operator or the parentheses, the get function. If you try to access a key that does not exist in the dictionary, using the access operator, let's say 4, this will throw an error, right? Key error, the key is not present in the dictionary. But if you do try this with get, this will just return none and not throw an error. And sometimes you don't want to interrupt the flow, right? If we look into the variable that was returned by this function, get, let's see, it is equal to d.get4, and I want to print the value. Look at the value inside the return. It's actually none. Let me print it. There we go. When we looked inside the variable just as this, right? This is a neat gimmick that Jupyter Notebook offers to us, that we get to peek inside variables by putting them in the last line of the code cell. And because none is a value symbolizing nothing, nothing gets printed out. But with print, the value inside actually gets printed. Okay, let's say we now want to delete a value from a dictionary. We can use the delete operator again, delete, and then the dictionary name with the associated key. Let's say we want to delete that 9 because I don't like the fact that it's a number rather than a word 9. And let's see how D looks like afterwards. 9 got removed indeed. The key value 9 got removed. With length, again, you can query the number of key value pairs in the dictionary, len d, and this should be 1, 2, 3. Look, there we go.